So please do rename yourself on the participants area by adding your company name as well. Jon, start. Let's go.
Thank you, Musin. All right, so I want to start by telling you a story of a couple of years ago. I was hired in as a data scientist with a company, and the company had a problem. They said it turned out that for every 10 customer that they had in their portfolio, they were experiencing an annual turnover in customers of around 20%. Now, this is of course made up numbers, but you get the point, hopefully. And their immediate reaction was that they needed a churn model. So they went to me and the data science team and said, hey, can you help us fix this problem? And being sort of an avid reader of all these sort of data science articles and online blog posts, I knew about a lot of these, posts on churn prediction models and how great of a success people were having with them. And I remember reading a lot of posts from sort of the big 3 consultancy companies about the success of churn prediction models. So I thought, hey, great, something I always wanted to try out, and here's an actual business problem to get us going. So we went into this problem head on, starting from scratch, spending 3 to 4 months on the sort of first cut model. So plowing through petabytes of data, trying out different types of models. And I think what we ended up with was fairly well, actually. So when we looked at the entire customer portfolio, what we could see was for everyone that we predicted to be a churner, 6 in 10 would actually churn. So that meant if we were to contact customers based upon this, we would get it right 6 out of 10 times. That's not too bad, given the complexity of predicting who's going to churn. And we would do so to say, well, this event is going to happen within the next 6 months. And we tried to balance it out. So what we figured is that, okay, so from all the people who are actually churning, within a given year, our model missed only 3 out of 10. So we would actually be able to capture 70% of all the churners, and we would, mostly get it right when we were contacting customers. So pretty balanced deal, and not too horrible of a performance to actually put to the test in the market. So that's what we did. We gave the model, we put it into production, we started scoring customers for testing purposes, and we gave those tests as leads to our customer retention team who were sitting offsite. And then we waited, and they started calling customers based upon our leads. And then they got back to us, and they said, well, they couldn't understand this because this didn't seem accurate at all. Only very few customers actually agreed to being about to churn when the customer retention representative called them up and asked them about it. And they also said it was super difficult to initiate a conversation with the customers because we know nothing about why they're churning. And as it turns out, it is actually really difficult to call up a customer and say, hey, we know you're about to churn in 6 months, because the customer might not feel, ready to admit that. But most of all, the customer might not know themselves. And we gave them, in the leads that we provided, we gave them no way of knowing why these customers were actually churning. So very, very difficult for them to actually implement in practice, even though the model was actually performing quite well. So we went back to the drawing board. We put in even more data, tried more algorithms, because we thought that there was a problem with the accuracy of the model. We added explainability modules that were sort of cutting edge at the time, tried to simplify everything, worked on different horizons of the churn. And we thought that after 2 more months, now we have it. It's great. Let's put it to the test. And so we did. We came up with something I think was fairly okay, given the complexity, that we could say, hey, for this customer, which you just got a lead on, the probability of them churning within the next 3 months is high. So it's above 95%. And here, let me show you exactly why that is. And we could give them a list of exactly what were the things that were caused, why we believed that they were about to churn, and how much of an impact did each of those have. So simple, intuitive, explainable, and most of all, we thought actionable. And so we put it to the test, and they came back and said, well, that's not helpful at all. And to add to that, they said, well, now we're just encouraging them to leave us. And so what we had missed is that what we found was that one of the biggest predictors for our customers leaving us was that they weren't using the product. And so by us calling them up, we were basically reminding them that they weren't using our product. And they got the great idea that maybe they should just cancel their subscription with us. And all of this turned into a bit of a fiasco. So we weren't using the churn model at all as intended. And instead, the customer retention team started making general I love you calls, and not necessarily based upon the predictions of the churn model. And so what I learned a little bit later is that there was a really good explanation for that. So you see, the company that I was hired in for, a couple of years before I started, they wanted to increase their market share and expand to other markets. So they said, let's get more customers, let's get them in fast, let's expand rapidly. So they were giving away their product for free for a fixed period of time. And true enough, they quickly gained a lot of customers. And so what was happening right after I joined the company is that the free subscription was running out. And funnily enough, a lot of these customers, they were leaving the company again. And so a lot of these customers weren't actually retainable because they were just trying out the product. So the churn itself wasn't really preventable. And on top of that, the turnover that we saw from the customers, it went both ways. So the company was gaining back customers at almost the same rate. So I thought, okay, this is a great reminder to not just jump in with both my legs, both feet. That wasting 6 months developing a churn model that wasn't really implementable in practice can be done better. And eventually I changed job into a new position with a new company. And it wasn't long before I heard the words, we need a churn model. And at that time, I hadn't really learned from past mistakes. So I still firmly believe the churn models were, had great promise. So we built a couple of churn models. We put them to the test. They were performing great and in theory. And we were thinking to ourselves, well, this is great, right? But it wasn't. They failed one after another. And I was really puzzled by this. So I started reflecting a bit more about what we were actually doing when we were building these churn models. And I didn't know what was going on. So I had an idea that I would, so instead of just jumping in with both feet, I would see if I could find out what was going on beforehand. And so I started asking the question, why? And they would respond with, our customers are leaving us. And I would again ask, well, why? And they might say, we don't know. And that's actually a great response because, I mean, we can find that out together, why they're actually leaving before we do anything else. But in cases where they didn't do that, they would say, maybe our prices are not right. And I would ask, why? And they would say, we don't want to race to the bottom. And I would ask, why? No, sorry, I wouldn't ask why again. There's no need to keep doing that. But in this case, there is no need for a churn model. The customers are leaving because the price isn't right. The company choose not to compete in price because they don't want to race to the bottom. It's a fairly simple example for where we think we need a churn model, but where we actually need a pricing model or nothing at all. And this is just one example. And it actually extends to most of the areas where we see churn models applied today. So there's loads of different reasons why customers choose to churn with us. non-competitive prices, poor reputation, inferior value offer, incomplete onboarding, bad customer experience, irrelevant product offers. Very few of these are fixed by churn. Most of them are fixed by something else entirely. Better prices, better public relations, better products, better onboarding flows, better customer experience, better product recommendations. And not all churn is preventable. So the question is, should I stop building churn prediction models? And yes, you should. In my honest opinion, you should shy away from churn models, at least if you haven't fixed all the other stuff. But I've heard that it works for telcos, so why is that? And that's a really good question. And one of the reasons why churn models work for telcos is that they use churn models as a way of matching prices to competitors. So instead of raising prices to the bottom, they wait until the customer is about to leave for a competitor, then they lower their prices. So they don't have to compete on prices, they just match it, but they only do it for the customers that are about to leave. I think this business model works well for telcos, but probably won't work well for most other companies. So if we're not focusing on churn models instead, but we still want to do really good things for our customers, we want to keep them happy, we want to retain them, what do we do then? Well, what we did is we stopped building churn models and instead looked for how we could be more relevant for our customers. And so that's what we've been doing for the past many years. So what we do and have been doing is to support our campaign activity. So building sales leads for our front line. And as a bank, what we do this in is with regards to home financing, investment, pension, credit cards. We've been doing this quite well, actually, building simple models to say, using historical data to say something about the customer's propensity to convert on a given product or purchase a given product. And we currently have some 70 models doing this, generating uplift in the area of 20% per product category. But there's a problem here with what we've been doing. And that's all we do here is started by a campaign, and that campaign is initiated by a human using their human intuition that isn't necessarily data-driven. So what we've been doing is saying, okay, so how can we actually go from something like this, from product focus, campaign focus, to something like this, where we put the needs of the customer in the center of our attention? How do we actually do this when we are a bank and we're not just able to use Salesforce for all our sales leads, given all the complexity and of our products, and that we have very few of them? And what I'm going to show you now is a look under the hood of what we're trying to do then. So let's say we start with a customer need, and what we really want to do is match that up to products, like we did before, but we want to start with a need and add the product later, instead of starting with the campaign. And to do that, obviously, we need to turn the customer into what we know today. That's data. And to us as data scientists, that's what they are. They're customers as well, but we need them to be data for us to work with them. And so we build a bunch of expert models, as I said before. So we keep those. They're great. They can tell us something based on historical sales. What's the likelihood that any given customer is going to buy this type of product in the near future? All of this gives us loads of different probabilities. We put it into an NBO engine, build some audiences, distribute that to our CRM system, which orchestrates and distributes the leads to our channels. But the important thing, the way to actually make this work, is this here. So I'm going to spend just a little bit of time explaining to you what it is that we're doing here, and how that's different from how we've done it in the past, and what it will give us in the end, the next best offer, that is. And very quickly, a next best offer is, it's a bunch of activities. In our case, a bunch of customer activities and interaction, events, so to speak, buying a house, being retired, all of that. Apply it with a bunch of weights, put in a little bit of business logic. There you have it. That's the next best offer. And that's still maybe a little abstract. So if we put that into a little more detail, what we have a bunch of probabilities of people purchasing a product. And then we add to that every kind of interesting thing that we can find. The utility of the customer, you know, what does the customer get from investing as opposed to savings? What's the profit for the company? What's the volume that the customer is going to buy? What's the timing, contact policy, everything really. And by putting all of this together, we get the sense of what the next best offer should be, not only from a customer point of view, but also from a company point of view. Oops. If I were to recommend that you would build this, I would say start with the probabilities. They're easy to do. They can be complex enough as they are. Get an understanding of exactly how much people are going to buy of that product and figure out where they're going to buy it. Forget everything else. Certainly wait with customer response feedback. That's going to be very, very advanced. Probably start simple. And that's exactly what we've been doing. We, have a little bit of maturity in the areas that I mentioned before, but we've only just started looking into all the other stuff. We still have our expert models. We still have our distribution channels. Now we're just trying to piece everything together to make the world make sense, and hopefully at some point add in those feedback loops to make use of the newest data. And that's what we're trying to do now. So basically, test, measure, and learn every time we do something to not end up in that, horrible churn case that I presented in the beginning. And to put that into context of a user journey or a customer journey, a typical home buying journey can take a year or more for any given customer. Where we come in are these small arrows here. We're all about driving conversion, but really we're all about driving conversion here. And for us in particular, we've chosen to start here to keep it simple. So that's what we're doing. In goes our models, into our MBO engine, out comes the leads to our advisors. That's what we do today. That's what generates all the value today. And it works. We have examples of one model generating 25 million euros a year, just one model. So you can imagine how making something simple can actually work if it's just applied all the way through the value chain. But of course, we want to do more. And as I said, we want to add the last part of the journey. But to do that, we need to add in a lot more web and behavioral data. We need to add all that third-party data because that's where the home buying journey starts. It starts way before they enter our channels. And hopefully we can start to add all the other digital channels at a later point in time. So summing up, how do you then actually realize commercial objectives with data science? Well, in my opinion, stop building churn models. That's not the way to go. That's symptomatic treatment. Go for something else instead. Build for relevance. Build cross-selling models, next best offers, product recommendations, anything that can help your customers engage and for you to remain relevant. Start simple, and in every regard, test, measure, and learn. And finally, question almost everything that you hear and question everything that you see. That was my 2 short examples for how to achieve commercial excellence with data science. Musin, I don't know if there are any questions.
Yes, so if you look at the chat area on the right, when you click the chat, you can see the questions. So they are slowly starting with the question. It's after lunch. You remember before COVID time, people are eating and it's, slowly starts. So thank you so much for the presentation, which was very insightful. Now, Lucia is writing, Wonderful presentation, definitely thought-provoking and brilliantly delivered. Thank you. Out of curiosity, our best predictive model, our best predictive model, did they turn out to be the complex black box-like models or simpler decision tree or regression-like models?
It depends on what you apply them to. I would say the simpler models, they're easy to build sometimes. They can give great performance. What's difficult for them is for us to apply them to complex areas where we have multiple product types and user journeys that we want to bundle into single models. So simpler models, great explainability. They require more in terms of maintenance because we need more of them. But they perform equally well when applied in the right way.
Thanks a lot. Another question and another question. So, Jens from Wordscape, great presentation. How is data provided for this? Real-time data lakes or more DWS style?
Yeah, definitely data warehousing. We're only slowly transitioning into data lake setup. But you can get really far with the data warehouse setup and even data that's slow moving. We're looking into now building a reinforcement layer to all of this to continuously and automatically learn and improve for our customers' interactions with our digital leads. But even that can be done in batch on a monthly basis. We don't have to learn every day. It's enough to learn every month, as opposed to now where we're not learning at all, unless we're retraining the model. And I can see there's a really interesting question here I want to answer. Someone says that they want to play the devil's advocate and ask, is customer retention actions a lost cause? Definitely not. But if you're not focusing on the root cause of your customers leaving you, then customer retention doesn't matter. So fix the root cause and add in the customer retention. So fix the underlying issue and do the retention. Don't just focus on the retention. That's not going to get you very far. Churn models I've seen, they work great in combination with all the other stuff. They're a great qualifier for the service level and care that you need to provide a customer when you are to come into contact with that customer. Gives you an extra sense of how sensitive you need to be with that customer when you engage with them. But they are very difficult to apply in practice.
Thanks a lot. Good stuff. Challenging Scania speaker as well. And the question is, how adaptive are expert domain knowledge based knowledge? Is there a risk that they become old news? They
do really fast, actually. So they can work well for quite some time, but often outside events, new products come in and they stop working. But what they do provide us with is that they provide a hot start for our reinforcement algorithms that we're trying so desperately to build now. So if we just start with reinforcement algorithms, we have to start completely at random. We don't want to do that. So we use expert and domain models to hot start the process and then add the reinforcement layer to continuously capture any new trends and customer behavior that occurs. And of course, we want to retrain our expert models, but probably at a slower pace than the reinforcement layer.
Thanks a lot. Yeah. So, okay, Gustav, if you have question, I can give you the mic because it was very good job. Jon finished it sooner that we have time for Q&A. Gustav, to give you the co-host because, or you have it already. Is co-host. Okay, Gustav, done with it. Yeah, go ahead.
Can you give me a video also? Thanks. I think it was a very interesting presentation, really enlightening because you often wonder how can you really make something that is not trivial, create trivial information from machine learning, because basically it's just a function between the features and the target variable. And as with the churn model, if the relationship is very obvious, then it doesn't provide value. So it's a very interesting journey you presented, I would like to say.
And I think that's one of the problems that I see a lot of time, is that I see a lot of write-ups, I see a lot of talks about A/B testing, reinforcement learning, churn modeling, and everything sounds great in theory, but everything falls apart when you apply it in practice. And if you really want to try that, it's very, very difficult to look up anyone else who've had that experience and I can actually explain to you where the pitfalls are and what you need to focus on. And that's why I say if you want to get on board with this, start out very, very simple. Don't do as I did. Don't spend 4 to 6 months, in a room locked up and then, starting the testing. Get out there fast with a very simple product to test your sort of assumptions, because I promise you, it's going to be more difficult than you expected, and it's not going to be because of the data or the algorithms.
So it's more about understanding of the real world.
Exactly.
Yeah. Dan, Gustav, we have one more question, if we can. Gustav, no more questions? Done?
Mm-hmm. There's a question here from Gary, I can see.
Yeah, I'm just giving him the mic to start, to make it more challenging.
Yeah. And infrastructure, I see as well.
Gary with us,
yeah.
Can you switch on the camera?
Yeah, sure. Hi, and hi, John, great presentation. We met briefly earlier. Thank you very much indeed. Some great examples. One of the challenges we see with our customers in the process of data science and any type of advanced analytics is that the teams are spending a lot of time finding, accessing, preparing data versus actually working with the data. So, that's probably not the most productive use of their time, and they're trying to change that model. So typically it's, somewhere between 60 and 80% of their time is spent finding and accessing and preparing data. How have you found that? What's the situation with your team? Is that a challenge for you?
Yes and no. I would say so. They spend 90% of their time preparing and analyzing data. Most of the time actually spent preparing and acquiring the data.
Yeah.
When it's just a matter of getting the right accesses, getting the data cleaned and all that because it's messy, I don't know if that's time spent really well. But a lot of the time, a lot of the footwork that is done in that period actually helps them get an understanding that they wouldn't have gotten otherwise. If data is just readily available, it's just too easy to build models sometimes. You can just churn out models that isn't applicable, difficult to integrate, doesn't work with a human in a human interaction. So I'd say it's a problem, yes, and our data scientists, they can get frustrated. But on the other hand, it's also a very, very necessary process to go through as a data scientist.
Yeah, that's a good point. Thank you. So it's like a balance, as you say. If they're not spending any time, if it's just thrown in their laps, they don't know what they don't know.
Yeah, if they have a data lake, a feature store, and a perfect production environment set up for experimentation, it's going to go wrong really, really fast, I promise you. Yeah.
But if you're able to speed up that process at least and make it easy, then it's still an important part of the process. But if you make it a lot easier, it could be more productive time-wise.
Absolutely.
Yeah, cool. Thank you.
Thanks a lot. So Sami, I just saw you coming on board. Sami has the presentation after you, but I wanted to make sure if Sami got the answer for the question. You had a question for Jon, yeah?
Yeah, I had a question and a kind of tears of agreement are rolling down my face. I think a lot of the points that John made resonate highly. So, but yeah, John answered it earlier on. So thank you for that.
Okay.
Perfect. Thank you so much, Jon, for giving us the time for Q&A. It is really appreciated. And I hope Sami will copy the same with questioning, giving us time for Q&A. Thank you so much, Jon. You can switch off the camera. Thanks.
I'll do so. Thank you.
Thank you. So, Sami, you introduce yourself.